Hi friends, today we'll solve a problem Leetcode 102, that is binary tree level order traversal. What is the problem is, given the root of a binary tree, return the level order traversal of its nodes values from left to right, level by level. Means this is the binary tree is given. So this is the root node 3, left node 9, right node 20. It has two nodes, left node 15, right node 7. So if I go level by level, this is one level, this is one level, this is one level. So first level is 3, next level is 9, 20, last level is 15 and 7. Okay, and if the level root is empty, output will be empty. If it is one level, one output. Okay, so how will we solve this? Level order traversal, when someone asks in binary tree, means it is a breadth first traversal, and breadth first traversal can be done using queue. So how will you solve this in queue? Means let's say I will take queue and insert this 3 on the queue, then we will insert the left 9, then right 20. Then in each node you will take it has any left node or right or not. So first 3, then 9, then 20. It doesn't have left node and root node, so we can not insert anything in the queue. In the 20 we will insert 15 and 7. So if we read the queue, it will be 3, 9, 20, 15, 7. Simple. But here the twist is that we need to print each label one by one in the array. Okay, so how to do that? We will do that by putting identifier. You need identifier. My level is end, right? So whenever my level will be end, if we insert a null node here, and when we encounter the null node, we can infer that that level is end. Okay, so in that approach we will do it. Here we will solve the problem using breadth first BFS algorithm, breadth first search. Using breadth first search means we need to use a queue, and as we need to print each label, so need a identifier to mark the label end. The identifier will be a null node. Okay, so this is the process we will try to apply here to solve this problem. Okay, we will solve the problem using BFS, using queue, as we need to print each level, so need identifier to mark the level end. The identifier will be a null node. So for doing that we need a queue data structure, right? But Swift doesn't have an inherent queue data structure. We will build that. We will build the queue using linked list approach. First we need a queue node, class queue node. That node will have some data, and this data will be tree node. Why I'm keeping this optional? Because as we had shown that we need a null node as well. This data can be null. Variable next, we will keep this queue node. Then we'll put integer initializer and this data will be a tree node, and this self dot data will be data. Now with the help of this queue node, we will create the class queue data structure. We know that queue is a FIFO data structure, right? First in, first out. It has two ends. One is front end, one is rear end. So through rear end we insert, from front end we exit. Okay, so let's develop to create two variable, front and rear. These are the queue node. Now what we'll do, queue has two methods, right? Enqueue and dequeue. Function enqueue, and here the what type of data we are storing, type of data is tree node we will insert. Okay, so with that we will create a queue node equal to queue node will be data. So now if front is equal to nil, so we can insert in empty queue, front and rear both will be null. So front will be node and rear will be node. Else means queue has some data from second node, as we are inserting through the rear node, so we can do that rear dot next will be equal to node and rear will be node. So as rear is front node, always the first node, because from front node we will bring out the that first element, so it should point to the first node first. That's why we check that first front node is equal to nil, insert that front equal to node, rear equal to node, then with the rear pointer we are inserting one by one node. Now rear equal to node is in both if and else case, we can remove it and put outside. Okay, now function dequeue. What it will return? It will return a tree node. And one temporary variable we will take, temp is equal to, what is the value? From temporary variable is front. Okay, as we are taking out the front value, so front should be, now the next element will be the front. So front equal to front dot next. Now we will return this temp dot data. Temp is a queue node, its data is a tree node, right? So temp dot data. Now we will check function is empty. If queue is empty or not, that we will check. Boolean. We will return if front is equal to nil, because we generally take out from the front node, right, to the queue. So front equal to nil, that check I put. So now in this level order traversal, we will solve the problem using this queue data structure. So first you will check that got let root, else we will return empty array. Root is null means there is no tree, it is a null tree, so it's a return this one. Now I will create the queue instance, equal to queue, this queue, and first queue dot enqueue, I will take the enqueue per method. I will insert the root, then I will insert, as we have traversal is not in a single line, each label has to be print, so there should be identifier. That identifier is a null node, by passing null. Okay, now while this queue is not empty, queue dot is not empty, queue is empty, we'll check. Okay, what we'll do, we'll take the first node. What is the front node? Let node is equal to queue dot dequeue dot dequeue. Now if my node is equal to null, means I reach the end of a level, and in that case if my queue is also not empty, means still my label is there, means in that case I need to insert again queue is null, because we are traversing from left to right, so whenever I am reached null in this label, means that insertion of the all the nodes at this level is finished. That's why I am adding queue is equal to null. This will understand later. Okay, I'll show you. So this res dot append is res means result. Okay, result I have not taken. Variable result is an two-dimensional array, and I will take a temporary array as well, and t this one. Now res is equal to, you will take the temporary value, sorry, this temporary array, and this temp we will make it as empty here. Now the else part, what this temp is doing, temp is an empty, temp is a temporary array that track of one label. Okay, so in this temp I will enqueue that node dot value, that as already checked it is not equal to nil, so no into force and wrap node dot value, and if my node is node dot left is not equal to null, then we can insert in the queue dot enqueue the node dot left, and similarly for right as well. If node dot right not equal to nil, so node dot write also we can write here, correct? Now, and we will return the result. So I will dry run this code. First this 3 came, 3 node, it is not empty, it will come here. In the queue I am inserting 3. Okay, now inserting null, then result is this array, empty array, 2D array, and temp is 1D array. Now queue is not empty. Yes, it is not empty. So node equal to dequeue, 3 node come, node equal to null, no. So node is not equal to null, it will come here. So it will enqueue temp dot amend, sorry, this is the mistake, node dot value 3 I have insert. Okay, then node dot left equal to not equal to null, is not equal to 9. So enqueue node dot left 9. Next right is also not equal to null, so node dot right. So now the queue position, if you see this till now, queue has 3 comma nil comma 9 comma 20. Okay, this is the queue's condition. Now again it will come here, queue is not empty, sorry, queue is already dequeue. For initial level here it was 3 comma nil. Now we have dequeue it, so that 3 is removed, so 3 will not be present, null comma 9 comma 20, this is the condition of the queue. So next it will come there, queue is not empty, so node queue dot dequeue, null will come, node equal to nil. If queue is not empty, it will insert again null, nil. So first 3 is that what we have removed, the 3 is part of the temp now. Okay, null, res is append temp, so res value is equal to 3. Now I have nil is also removed, so 9 comma 20 comma null. So now I'll come here again, queue is not empty, dequeue 9 is dequeued, then node dot equal to no, come here, append node dot value 9. Okay, so temporary the 1D array has 9 value, it both the node is null, so it will not append anything. So now it will come back to here again, so queue is dequeued and it is part of this 1D array. 9 means if I write the temp for your purpose, now this is has 9. So now queue will dequeue what, 20, equal to nil, no, come to else part, temp dot append node dot value, what is the value, 20. Okay, it is removed, now it only null. So now it will insert 20 node dot left equal to null. Yes, so node dot left we will insert 15, then right is also not null, so insert 7. Okay, so null, so again it will come to node, it will dequeue, value is nil. Yes, queue is not empty. Yes, queue is not empty, so queue dot enqueue is equal to nil. So here I will pass nil. Res dot append temp is 9 comma 20. Okay, now it will come back to here, this part is removed, right? This part is because null I checked and it is removed. Now you can come to here 15 node equal to nil. No, temp dot append equal to value. So temp is I have put here, so it is empty now. So now 15 temp append, left right both are null, so it will not insert here. Come back to here, q7 is removed from the queue. So 15 is removed from the queue. Now 7 is removed from the queue. So 7 is removed from the queue. So 7 is running now. So not equal to no. Here append is equal to 7. Then both are null. It will not enqueue here. Then it will come back to here. Check the null. Yes, null also moved. So it will check the node equal to nil. Yes. Queue is not empty. No. So res will be append temp. So it will be 15,7. So and this is also empty, and they return the res value. So this will be the last value of res, which is the expected one. So now we can run this. Three comma null. Oh, I have here written. Okay, no issues. Accepted. So all the test cases, and I am submitting now. Yes, this is also accepted. So now my pace complexity and time complexity. So here you see that I am traversing over all the nodes. So time complexity is order of n, and as I have taken a separate data structure Q and entering all the nodes, so space complexity also order of n. Okay, so that's it for this problem. So if you like this video, if it is I'm able to give you some knowledge, please like this, and if you want to get this kind of videos in future, please subscribe my channel, and please comment also if you have any doubts or you can see some improvement in my implementation. Thank you.